Okay, so again, tomorrow is the last day to hand in any of your missed assignments. Your final exam is scheduled for Friday at 8:30 in the morning. Again, that's different than what's on the exam schedule. So make sure that you are here Friday morning to write your final exam. And that means that next week, when Block 1 exam is scheduled, which is on Tuesday, January 24th, you don't have to come to school that day. Okay? So last day for assignments is tomorrow, and Friday morning, 8:30 is when you write your final exam here in this room. So I'm going to do bits and pieces of the next few lessons here to finish off the course. Again, just with different things that happened this year, we didn't have any time for final exam review, but I've put on Google Classroom, there's a tab there for final exam review. There are final exam review assignments that you can be looking at, as well as the keys to those assignments. So you can go back and do some of those questions or look at what's on there as review for your final exam. So, number one, surface area of an official 5-pin bowling ball is approximately 459.96 centimeters squared. What is the diameter rounded to the nearest tenth? So you have to realize that a ball is a sphere, and we saw that the formula for surface area of a sphere is 4 pi r squared. Again, you'll be given a formula sheet with all the formulas on there. You don't have to memorize them. Okay. However, you do have to have an idea of when you look at a shape, you have to know what shape it is. You have to know when you look at a cylinder that it's a cylinder, because sometimes you're going to be given a picture of a shape, and then the formula will be there, but there's no picture on the formula sheet. So you should be able to look at a shape and know what kind of shape it is so you can pick out the right formula off the formula sheet. In this case, we're told the surface area is 459.96 centimeters squared. So our only option is to find r, the radius, which is okay because then you're going to double it to get the diameter, which is what the question is asking for. Okay? So I'm going to divide both sides by 4 pi. You can do it in 2 steps. Divide by 4 first, divide by pi second. That's fine. But we've done questions like this before. When you divide by, in this case, 4 pi, you must put the 4 pi in brackets so that it all stays in the denominator. If you don't put it in brackets, your calculator will divide the 459.96 by 4, and then it'll multiply that answer by pi. Christy, put your phone away. Your answer then will be over 6 times greater than it should be. So the 4 pi must be in brackets if you do it all in one step. And that gives us 36.6 approximately centimeters squared equals r squared. So now to get r by itself, to get rid of the squared, we do the opposite, which is square rooting. So we take the square root of that entire number, the previous answer, and it'll be 6.05. That's r. If I rounded that to 2 decimal places, centimeters, and then you have to times it by 2 to get the diameter. So the diameter, would be 12.1 to the nearest tenth. And we should use approximately equal to because it is being rounded. And so there's the answer for the diameter. Right, so sometimes you're going to be given the surface area and you want to find one of the missing dimensions. Number 2, a closed box has a surface area of 126 inches squared. So the closed box just means that it is completely enclosed. The lid is on there. We will see, or we've seen questions in the past where there's one piece missing. Christy, do I need to take that away from you? I'm sorry? All right. But we saw that the formula for surface area of a box is twice length times width plus length times height plus width times height. And those parts inside the bracket can be in different order. It doesn't matter. You could have the length times height first, the W times H first. It doesn't matter. We are told the base of the box is 5 inches by 3 inches. We want to find H, the height. So if we say that the 3 is the length and 5 is the width, it actually doesn't matter. We could switch those two around. Doesn't matter. But if that's what we say, then the surface area, which is 126 inches squared, will equal 2 times. The length is 5, the width is 3, so it'll be 5 times 3, plus the length is 5 times H, the height, plus W, the width, which is 3, times H, the height. So this is now what we need to work with to solve. I would start by dividing both sides by 2, because that 2 in front of the bracket means it's 2 times everything. So we can do the opposite of multiplying by 2, which is dividing by 2, and those 2's will cancel. And when you divide 126 by 2, I think you'll get 63. Yep. So 63 will equal. Now, inside the bracket, you have 5 times 3, which is 15, plus, then you have 5h and 3h. Those can be added together. They are like terms because they both have the same variable with the same exponent. They're both h to the power 1s. So you can combine them. We did that when we did our polynomials unit. Right? So that's what we have right now. So now we need to get h by itself. So my next step is I would subtract the 15 from both sides. I'm going to subtract 15 from both sides. So 63, take away 15. Yeah, 8h. So subtracting this 15 from both sides, we're left with 48 on the left, equaling 8h on the right. And now we would get h by itself by dividing both sides by the 8. And 48 divided by 8 is 6. So 6 inches will be the height of the box. Okay? Ella, we're on measurement. The booklet is over there on top of that metal cabinet. You have it? Okay. And we are on page number 19. Okay, number 3, you're given the cylinder. You're given the surface area is 47.4 square meters. Calculate the missing dimension, which would be the height. So the formula for surface area of a cylinder is 2 pi r squared plus 2 pi rh. We're told our surface area is 47.4 meters squared. We do not know what h, the height, is, but we're given the diameter is 1.3. Remember, the radius is half the diameter. So we'll divide the 1.3 by 2 and get 0.65. And that is in meters. And the first term of that formula, r, is squared. And then the second term is 2 pi times r, which again is 0.65 meters, times h, the height. we need to solve for h. Okay, so I can take my calculator and find the value of that term that I've just underlined in blue. I can go 2 times pi times 0.65 squared gives me that number, 2.65, and there's more decimals there. It's an irrational number. Because it involves pi, that decimal never stops. Never repeats, never stops. So I'm going to store it into memory slot A because chances are I'm going to need it again here. Because that will be my next step, is to subtract both sides by that value. But right now I have 47.4 meters squared equals 2.65, and I just rounded it off to write it down, plus, now on the right side I can do a little bit of simplifying by multiplying 2 pi by 0.65, not 0.65 squared, just 0.65, which is 4.08 meters times h. And I'm going to store this number into memory slot B because I'm going to need it. So, as I said earlier, I'm going to subtract the 2.65 meters squared from both sides. 47.4, take away that 2.65, but again, we need to use the entire decimal. I've stored that number into memory slot A, so that allows me to use the entire decimal. And this gives me 44.75 if I round that off when I write it down. 44.75 meters squared equals 4.08 m times h. So the m just stands for the meters. We're going to divide both sides now by the 4.08 meters. That looks terrible. And that number, the 4.08, I stored it into memory slot B. So I'm going to divide by the number in memory slot B. And this gives me h to be 10.956. And in this case, it asks us to round to the nearest tenth, which actually would become 11. Because the digit in the 10th place is the 9, but to the right of that is a 5. So the 9 has to go up. 10.9 would have to go up to 11. H would be approximately 11 meters. That's the height of that cylinder. Okay, so I mean, these next ones on the next page just deal with different shapes, but the questions are all done the same. So what I'm going to do is I'm going to move ahead to lesson 8, where we're talking about volume. It is the number of cubic units, right? Area is always in units squared. Volume is in units cubed. It is the number of cubic units that are needed to fill the inside of a three-dimensional object. Capacity is a measure of how much it can hold. Okay, so some examples where volume might be required would be, let's say, filling a swimming pool. That's an example of where volume might be used. A person would want to know how much water it's going to take to fill up that pool. Another example of volume might be the size of a soup can. How much soup can it hold? Okay, so those are examples of volume. And we have some formulas for volume. The first one is a box, a rectangular prism. The volume of a box is length times width times height. And those can be done in any order. When you're multiplying numbers together, order doesn't matter. So again, all these formulas are given to you on a formula sheet. Don't have to memorize them. Just got to know how and when to use them. A triangular prism, the volume of that, remember that a triangle is half of a square or a rectangle. So the volume of a triangular prism is half the volume of a box with the same dimensions. So it is length times width times height divided by 2. The volume of a cylinder is pi r squared times h. So again, these are all in the formula sheet. Don't have to memorize them. And the volume of a sphere is 4/3 pi r cubed. That is the same thing as 4 pi r cubed all over 3. Right? They mean the same thing. So volume is how much will fit inside of a shape to fill it up completely. And it's always in units cubed. So for question number 1, we're asked to find the volume of these shapes. This is a box. The formula for volume of a box is length times width times height. And it doesn't really matter what you say is the length, what you say is the width. I think it's fairly obvious that we would say that 4 was the height, but it actually doesn't matter. You're just multiplying 3 numbers together, and the order you multiply them in will not change the answer. So you're going to multiply those 3 numbers together. 10 times 6 times 4, 240. And because you're multiplying centimeters times centimeters times centimeters, that's centimeters cubed. So what does this mean? Well, what this means is if you had small little boxes that measure 1 centimeter by 1 centimeter by 1 centimeter, 1 centimeter long, 1 centimeter wide, 1 centimeter high, it would take 240 of them to fill that up completely. That's what it means. Because it's in centimeters cubed, if you had little boxes that measure 1 centimeter by 1 centimeter by 1 centimeter, it would take 240 of them to fill that up completely. The next one is a cylinder, and the formula for volume of a cylinder is pi r squared times h, the height. So we're given all those values. R is 6 meters. That needs to be squared. The height is 14 meters. So it's pi times 6 squared times 14. So 1583.4. And remember, it's always in cubic units. In this case, meters cubed. So I mean, that's a big cylinder. It could be a giant storage container for gas or some kind of something in the oil field. I mean, if you drive between here and Edmonton, between Fox Creek and Valley View, I think Pembina has a big site right on the highway where they got these massive, and they're cylindrical storage tanks for oil and gas. Closer to Fox Creek, there's another big site there that Pembina has. Massive cylindrical tanks that they use to store their oil and gas products. Okay, so it'd be like this. So what does that mean? Well, if you had boxes that measured 1 meter by 1 meter by 1 meter, that's how many it would take to fill up that tank completely. How many of those boxes that measure 1 meter by 1 meter by 1 meter? Okay, this next one is a sphere, and the formula for surface area of a sphere is 4 pi r cubed over 3. So all we need to know is the radius. Like pi is an actual number, 3.14, and it goes on forever. The only variable we have here is r, the radius, which we're told is 75 centimeters. That needs to be cubed. And we can put this entire expression in our calculator. 4 times pi times 75 cubed. And because there's only one thing on the bottom, only the 3, we don't have to put it in brackets when we divide, excuse me. We can just go divide it by 3. So, there's our answer. It's a big number. 1,767,145.9. And that would be in centimeters cubed. Okay, big number. Let's skip down to the one directly below the one we just did, because this is a triangular prism. And the formula for the volume of a triangular prism is length times width times height all over 2. So the length of this is 6 inches. The width would be 2 inches. And the height is 2.5 inches. So 6 times 2 times 2.5 divided by 2 gives us exactly 15. And that would be in cubic inches. And for the next one, I mean, it's just the same type of shape, but it's actually sitting on the triangular piece instead of sitting on a rectangular piece. But it doesn't matter. It doesn't really matter what you say is the length, what you say is the width, what you say is the height, because when you multiply 3 numbers together, order doesn't matter. So you're going to multiply 5 times 10 times 7 and divide by 2, and that'll give you your volume. Okay? Let's look at number 2 on the next page. The Smith family had a circular pool which was sunk into the ground. They had it removed. This left a cylindrical hole which needed to be filled. The pool had a diameter of 40 feet and a depth of 5 feet. Mr. Smith's pickup box has dimensions 5 by 3 by 7 feet. How many level loads of dirt will be required to fill the hole? Round to the nearest load. So we're going to have to do 2 things, actually 3 things. We're going to have to find the volume of the cylindrical hole that was left behind. We're going to have to find the volume of this pickup box, and then we will divide those 2 to see how many loads it'll take. So, volume of actually let's call it the hole, not the pool, because the pool has been removed. The volume of the hole. And it's a cylindrical hole, so that is pi r squared h. So we're told the diameter was 40 feet, so therefore the radius would be 20 feet, half the diameter. And it has a depth of 5 feet, so that's the height. So we'll go pi times 20 squared times 5. That gives us 6283.2 approximately. And that would be in cubic feet. So again, what that means, if you had boxes that measured 1 foot by 1 foot by 1 foot, this is how many it would take to fill it up exactly. Because it's a cylinder, rounded sides, some of those boxes would have to be cut in order to make them fit. But this is how many it would take in order to fill it completely. So that is the volume of the hole. Now I should store this into memory because I know I'm going to need it into memory slot A. Now we'll find the volume of the truck box. Right? It is a box, so it's just length times width times height. So his box measures 7 feet long by 5 feet wide by 3 feet deep. So 7 times 5 times 3 feet. 7 times 5 times 3 is 105 cubic feet. So again, to get the number of loads that he needs to fill up that hole, we will divide. Take the 6283.2 and divide it by 105. So that 6283.2 I stored into memory slot A. I'll divide it by the previous answer, which is 105. 59.8. In other words, we'd have to round that up to 60 loads. That's how many loads of dirt he would have to haul in his truck in order to fill up that hole completely. That's a lot of work. Okay? So now let's go on to 7.9, because this involves a couple different shapes. We've done surface area of cones and pyramids, but now we got to do a few questions with volume. The volume of a cone is pi r squared h divided by 3. The volume of a cone is related to the volume of a cylinder. The volume of a cylinder was just pi r squared h. This is 1/3 of that. So a cone is just a cylinder that has been cut apart, and 2/3 has been taken away, so you're left with 1/3 of the cylinder. That's what it means. And the formula for volume of a pyramid is a box, again, that has been cut away. 2/3 of the box is cut away, so there's 1/3 left. That's why the volume of a pyramid is related to the volume of a box cut by a factor of 1/3. Length times width times height divided by 3. So those are the two formulas that we use for this portion. Question, or the first one there is just a cone, so you'd use the formula. The second one, same type, except with the first example, you're given r the radius. The second example, you're not given r the radius, you're given d the diameter. So r the radius would be half of the diameter. Half of 40 millimeters would be 20 millimeters. So this is the formula that we would use for volume of this cone. Pi r squared h divided by 3, and we found that r the radius is 20 millimeters. The height is 50 millimeters. And that's all divided by 3. So pi times 20 squared times 50. And again, because you're just dividing by one number, you don't need brackets when you divide by 3. And so our answer is approximately 20,943. And actually, if we round to the nearest tenth, the digit in the 10th place is a 9. To the right of it is a 5, which means 943 must go up to 944. And that would be in cubic millimeters. Yeah. Okay, and on the next page, those are pyramids. The formula for volume of a pyramid is length times width times height over 3. If we say the length is 5 centimeters, the width is 4 centimeters, and the height is 8 centimeters, and it doesn't really matter, we can switch the length and width around, doesn't matter. When you're multiplying 3 numbers together, order doesn't matter. So it's 5 times 4 times 8 divided by 3. So that is a number that we're going to have to round, 53.3. And that would be in centimeters cubed. This next one, you're given an extra dimension there. You're given the length along the edge. You don't need that. To find the volume of a pyramid, it's again length times width times height divided by 3. The height is measured from the very tip straight down to the middle of the base. So in this case, that's 24 feet. You're not going to use the 30 feet for this one. This extra information that you're given, we don't need. So if we say the length is 17.5, the width is 32, and you can switch those two around, it doesn't matter, but the height must be 24. You're not using the 30 feet in this case. You don't need to know what the length of that edge is. So 17.5 times 32 times 24 divided by 3 gives us 4,480. 17.5 times 32 times 24, yep, divided by 3, 4,480. Exactly. And that would be in cubic feet. Okay? And, I mean, you can be given questions where you have composite shapes. You can find the volume of a composite shape by finding the volume of the two pieces that make it up. And in this case, when we did surface area of composite shapes, sometimes we said if when the two shapes meet together, you would not include those dimensions for surface area, but it doesn't affect volume. Volume is capacity, so where two items are joined together, it doesn't affect the volume in any way. So you wouldn't have to make any adjustments to any of the formulas for that. So if we just look at example 2, if we wanted to find the volume of the composite shape, it would be the volume of the box. In this case, you'd have to then subtract the volume of the cylindrical part that's in the middle. You'd have to subtract those two. So if volume 1 is the box, that's length times width times height, or 6 centimeters times 6 centimeters times 6 centimeters. That box is actually a cube. All three dimensions are the same. 216 centimeters cubed. And then volume 2 would be the volume of the cone that has been cut out. Pi r squared h over 3. Again, you're given the diameter to be 4 centimeters, so r, the radius, would be 2 centimeters. The height of this cone is the height of the box. They're the same number, which is 6 centimeters. So now we'll go pi times 2 squared times 6 divided by 3. 25.13. And then our final volume will be the difference between these two. So 216, take away our previous answer, 190.9 if you round to the nearest tenth centimeters cubed. Okay? So we'll stop there for today. I'll hand out assignment, I think 7.9, so you can do some questions with volume for practice. I will post the solutions on Google Classroom. So again, tomorrow is the last day to hand in any missed assignments. Also, your final exam is Friday morning here at 8:30. So make sure you take note of that because it's different than the day on the exam schedule. And that again means that next Tuesday, when the Block 1 exams are happening in the afternoon, you don't have to be here. Okay, you get Tuesday off. All right.